All right, so we're looking at number 6 on page 10. Here we go. We have 2 cents, and then 6 cents, and then 18 cents. So the first thing we do is say to ourselves, this is an example of a geometric sequence, right? Okay, so let's read the question. How much money will be on the 18th square? Now, I am going to give you the formulas. Where geometric is concerned, you have 3 formulas. Here they are. So you have to decide which of those formulas is appropriate to find how much money on the 18th square. What do you think?
First one.
First one. We aren't interested in adding up a bunch of stuff. We want to know what's the 18th term. According to the formula, the 18th term will be the first term times the ratio to the n minus first. Right? Now that is going to be a gargantuan number. What will be the unit on that? You're going to come out, you're going to get an answer. What will be the unit on that answer? Cents. We do not answer in huge numbers of cents, right? So we're going to change that to dollars. And how do you change a number to dollars? You divide it by 100, right? Or move the decimal point 2 places. So you're going to want to be sure to do that, or you're going to lose a little bit of credit.
Are we going to have the formulas like on the quiz?
I believe I've answered that question already about 30 times, Mr. Small, including about 2 minutes ago. I said I'm going to give you the formulas.
Okay.
Okay? Shake that head, get those cobwebs out. We're looking alive. All right, B. How much money will be on the board all together by the time he gets to the 24 square?
You have to find the sum.
Sum. You got 2 sum formulas where geometric is concerned. Which one do we want?
First one.
The first one, because this one's only used when?
Infinity.
Are we just adding money to this board forever and ever and ever? No. We want to know what happens when you get to the 24th square. So the formula says 2 minus 2 times 3 to the 24th over 1 minus 3. Please, before you put this into your calculator, make that a -2. And then go ahead and put it in. 2 minus 2 times 3 to the 24th equals divided by -2. Again, it's going to be a huge number. What will be the unit on that? No. The unit on this is going to be cents. So again, you're going to move that decimal place 2 over or divide by 100 so that you can answer in dollars. But it will be another very large number. Okay, Andrew? All right, anybody else that did the homework have a question on page 10? Tracy? 4. 4 is a recursive formula.
So if there's I, there's 2I. So if there's 3I, there's 3I. Put them all on the
Would you add them all up and divide by?
And with a recursive formula, we have to build it from the bottom up. It's kind of like Pascal's triangle. If you want the 5th row of Pascal's triangle, you have to build all the other rows, right? That's how this works. So they tell me that my first term is 1. That's given. Now I'm going to find my second term. So to find my second term, I'm going to let n be 1. Because if I let n be 1, what does this say?
2.
A sub 2. A sub 2 equals what? I'm letting n be 1. So what's this going to say?
2.
2a sub 1 plus 4. But what do I know about A sub 1?
It's 1.
It's 1, so I can plug that in, and it, and it looks like A sub 2 is 6. All right, now I'm going to find A sub 3. Now how am I going to find A sub 3?
A sub 2.
I'm going to have to let n be 2. Because if I let n be 2, what does that give me? A sub 3, which is what I'm looking for. So A sub 3 will be 2A sub 2 plus 4. Kids, you're letting n be 2. It isn't confusing, it's not hard. You let n be 2. And the equation says A sub 3 equals 2A sub 2 plus 4. But what do we know about A sub 2? It's 6. So we just plug it in and we get 16 for A sub 3. Now, how do we find A sub 4? We'll let n be 3, because then the equation will say A sub 4 equals 2A sub 3 plus 4. But A sub 3 is 16, so 2 times 16 plus 4, I got 36. And then finally, I can do A sub 5, which is what the question said. What will A sub 5 equal? 2 times A sub 4 plus 4. But A sub 4 is 36, so that'll be 76. So the answer is 76. Building it one term at a time. Number 2, what does that symbol mean? Sum. So I am summing up. Now I've erased them, but I have some sum formulas, don't I? I need to figure out which of those sum formulas I'm going to use and what's it going to hinge on.
Finding the sum.
I'm finding the sum, yeah, but I've got 3 sum formulas. How am I going to decide which one it is?
You're going to do it.
I have to first of all figure out what kind of series I've got. Is it arithmetic or geometric? And how did we decide we were going to do that? Start plugging in numbers until we saw the pattern develop. So we'll start right here, plug in 1, and we get -1. Then we plug in 2. And 3, and you're technically going all the way to 100, from 1 to 100. You don't have to go that far. You just go far enough to figure out what's happening. What's happening? We're adding 2. So we have an arithmetic sequence, right? And we want to add them up. So the formula for that is this. What's n? 100. I'm adding up 100 terms. N is the number of terms you're adding up. I'm adding up 100 of them. Right? So the formula says, okay, that's 100 over 2. What did you say A sub 1 was? You already figured that out. -1. This would be A sub 100.
Define that.
So we're going to plug in 100. And A sub 100 would be 197. And we'll just do that arithmetic on our calculator, and we will have the answer. All right, let's look at page 9.
This is the one where you all the letters, verse 19, and then there's like 3 I's, 3 S's, 2 O's, 2 S's.
Okay, we're on page 9, so here we go. Number 1 is another recursive pattern. And this time we are looking for A sub 4. All right, so here we go. How do I even get this thing started? That's the given, all that's given. I let n be 1, and if I let n be 1, what does that equation say? If you put a 1 in for all the n's, what does that say? A sub 2 equals?
A sub 2
2
equals
a sub 1 minus 3, right? Which would be 2 times 5 minus 3, which is 7. All right, next, let n be 2, what's it say? 2 a sub 2 minus 3, which is 2 times 7 minus 3, which is 11. And finally, the one we're looking for, this time we only want the fourth one, that'd be 2 times the third one minus 3, so 2 times 11 minus 3, I got 19, did you? Number 2, we just did this. It's a different problem, but it's exactly the same scenario. How do we start?
Find the sequence.
Figure out what kind of sequence you have. So we'll start by putting in 1 and we get 6, and then we'll put in 2 and we get 8, and 3 gives us 10, and we'll keep going, this time to 16, until we figure out what's going on. What's going on? It's arithmetic. We're adding by 2, so once again that formula is this one. How many terms are we adding up this time? What's n?
16.
16. What's the first term?
6.
6. You already figured that out. What's the 16th term?
36.
36. Plug this in. That's how you got the 16th term. Didn't you get the first term by plugging in 1? Yeah, it makes sense. Figure out what that is, and that's the answer to the question. 3a, what's the limit there? Negative 4. B? 0. C? 6 and 1/2. 6.5, 6 1/2, 13 halves. D? Divergent or no limit. E? 0. All right. Katie?
Why is 3B 0?
What did you think it would be?
I just didn't know what 2 was. I just don't know how you got 0.
Somebody tell her.
But like,
You just ignore that.
It flips back and forth, positive to negative, but every time it flips, it gets smaller. So it's heading towards 0. Okay, number 4. We got a ball dropped from a height. I'm not going to do every single one of these. I'm going to do a couple of them. Number 4, we have a ball dropped from a height of 10 feet. Okay, so here's what it looks like. Here it is, dropped from a height of 10 feet. Each time it bounces, it rebounds 2/3 of the distance it fell. So here is the ball. Bouncing up and down, up and down, up and down. Okay? It rebounds 2/3 of the distance it fell. So what will this be?
2/3.
62 thirds.
Yeah, 20/3. 2/3 times 10, right? And then, of course, that's going to be the same. What's this going to be then? 49, and so on. So if we look at the downs, they start with 10, and they form a geometric progression. Would you agree if we look at the downs?
Yeah.
Now, how long are we letting it go? How far will it have traveled before it comes to rest? What do you think?
It's infinity.
It's infinite. It's infinite. So we're going to sum up the infinitely many bounces of this ball. What's the formula? Well, I know what it is.
They're all cut off.
So what's the first term?
10.
10. And the ratio is 2/3. So wouldn't that be 30?
Yeah.
Now, that alone is not the answer to the question, because remember, that was just the downs. Now let's look at the scenario. What can you tell me about the ups? Are they exactly the same?
Yeah.
Is there an up here? So the ups would start here, wouldn't they? So don't the ups match the downs except for this?
Yeah. So that's not the first term.
So if the downs were 30, what will the ups be? 20. So what is the total distance? 50. Remember, we added all the downs and got 30. The ups were exactly the same, except they didn't have this 10. So if the downs were 30 and the ups were the same, except they didn't have the 10, they would be 20. And the total distance then would be 50. All right, we're not doing number 5, or number 4, or actually there's 2 5s. We're not doing the first 5, let's look at the second 5. We have 7, 14, 28. How many will I have taught in 8 years? All right, so first of all, what kind of sequence do we have? We have geometric.
I'd like to hear.
Do I want an A sub n or do I want an S sub n? How many will I have taught in 8 years? Don't I want to sum them up? Don't I want to have a total? What would it say if I wanted A sub n? How many in the 8th year? That isn't what it says. It says how many all together. So the sum of 8, the formula is this. So the sum of 8 will be 7 minus 7 times 2 to the 8 over 1 minus 2. Remember, these are the ones, take care of that denominator before you start. Type in the numerator, hit equals, and then divide it by. Brian uses 2 markers, 5, 8, and so on. How many markers will he use on the last day? Okay, well, first of all, are we arithmetic or geometric? Arithmetic. Do I want an A sub n, do I want a term, or do I want to add up a whole bunch of terms?
You want a term.
I want a term. How many will he use on the 180th day? So I need the 180th term. The formula for an arithmetic sequence is this. So the 180th term will be the first term plus the common difference times 179. That's how many markers he will use on the 180th day. Remember, kids, when you read one of these problems, there are 2 questions that must pop into your head. Arithmetic or geometric. You're going to figure that out by looking at the terms. And then, do I want another number in the list, or do I want to add them all up? And you have to figure that out from the grammar in the problem. Mrs. Ford assigns 10 problems on the first day, 30 on the second, 90 on the third, and so on. What have we got here?
Geometric.
Geometric. How many will she assign on the 21st day? I'm looking for a term. The term of a geometric sequence is this formula. So I want the 21st term. So that'll be 10 times 3 to the 20th. That will be some giant number. It'll go into scientific notation, and you'll just have to deal with that. All right, any last minute questions?
Give me just like 1 minute. This is for, do I need these out there?
Stuff like this.
Yeah.
Okay. I didn't know if I could just leave it like that. I might need a bar.
There better not be no downs thing.
There's something about the cards.
Oh, your son. Yeah. What do you have to say? Thanks. Celia.
Yeah, you have to run them. Let me get my formulas written down. Get in a seat where you can see the formulas on the board. I made them great big. Oh.